let us continue. From this point, it would be, I think, a little bit harder. But I want you to imagine Pokemons. You know, those Japanese creatures that like have evaluation. No? Okay. And we are going to evaluate right now the first term we have learned, average, which was mean, into weighted average, weighted mean, and these will be evaluated to expected value. So we'll start with mean, then change it a little. We'll have weighted mean, change it a little, and we'll have expected value. But at the heart, those all creatures, all values, are the same, and they output the same result. Okay, but we are using each instrument on a different data. So if we want to calculate the average, if we have all, like if we have a sum with all the sum of points, we'll use the mean. But in other cases, we might not be able to use just simply the mean to average, to calculate the average. Okay? Let's see what we have here. In this case, we have the data. This is our data, which has around 11 rows. It is easy to calculate the mean in this case. We just paste, okay. Sum and mean. It is easy to calculate the mean in this way. We can just write out how it was in the average in Hungarian. Outlook? No. We can outlook. We just can calculate the outlook. Outlook. Outlook of these values, okay, and we'll have the data, which will be the same as summing those values up. I don't know how to sum in Hungarian. In Maya, sum.
S-Z-U-M.
S-Z-Z-U. Sum.
That one, yes.
Sum.
No, not that one. The
U.
with a U.
Sum.
Yes.
Sum all the values. Count all the values. How to count? Count all the values, which will give me an error. Like count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Count the values and divide the sum by the count, and we'll have the average. Okay? We'll have the average. But our data may not be given to us like this. It might be given like this with frequencies, like the scores and how much they appear. Like for example, in this case, the 5 appears in this data table 2 times, so it has the frequency of 2. 6 appears 3 times. 1, 2, 3. So it has the frequency of 3. And the rest holds 2. So in a big, let's say, factory, you might not have the data for individual cases. You may have a table that says that 40 people earn 100,000 euros. 16 people earn 250,000 euros, and so on. How to calculate the average value in this case? The philosophy is the same, because in this case we summed 5 plus 5. No? If we change the places in summation, the summation doesn't change. The same holds here. We are summing 5 2 times. So we just can write here that we are multiplying 5 by 2. So multiplying the number by its weight. 5 times 2.
It's not
And we can do the same for the rest numbers. Let's check it out. So 0, we can 0. We have 0 only once here. 0. 0. 0 multiplied by 1 is 0. Okay? And we sum all these numbers. So, and we sum all these numbers. So the scores, the instances with their scores multiplied by their instances. If we sum this, we'll have zoom. We'll have the same number 74 that we have here. So in weighted sum, that has the following equation: sum wi, weight I, xi. The top part is the same as in simple average, which was sum of all x's. Okay? So the top part is the same, but we are weighting the, like, let's put J here to not be confused. Okay? But this is summing the same thing sum we have here. Okay? But we have the weights, which gives us the instances. Okay? And if we sum the weights, and if we sum the weights, we'll get 12. Okay? Now if this,
which was this and one. Those are
it's count. I don't know how count is in. I just counted.
Okay.
Count, like the function must be in English count. I don't know how to let's find out. We will have Excel translator, Excel
it's good.
translator, Excel translator. I hope this is correct. No, Excel translator.
But we can put in English. I think you should.
Excel translator, and we are going to translate from English to Hungarian, English to Hungarian, Major, Hungarian, and we are going to count. Count.
No, it didn't change.
Darab. The function is darab. Okay?
No.
So we can put darab here equals the
No, we have to after that we
Darab.
have to set okay, so
and it will count.
this one, yeah, this one. Okay. And you have to start with the same tool. You have it in English. So you have to
This is one of idiosyncrasies of Excel, that it translates all the functions, okay? There are more idiosyncrasies in Excel. Excel is a power tool that can be used in a lot of cases, but if you have a big database or a difficult thing to run, I advise against using Excel to do so. I've been there, I've done that. It is better and easier to use statistical languages, I don't know, Python, R, or others, to write a program to deal with big databases or with complicated models. Excel can do that, but in the cases of huge things, Excel is prone to error. Okay? And Excel is slower if you have big databases. So but Excel is visual. That's why it's easy to understand and learn what is going on. Okay. So we summed all the multiplications of instances with frequencies, and we got the same as just summation of all those rows. This is intuitive because we just changed the sums, but if we change the sums places, the summation doesn't change. Okay? Do you understand this? Okay. The same goes with frequencies. If we sum all the frequencies equals third. If we sum all the frequencies, we'll get 12, which will be the same as counting or as product of all the numbers. Okay? So this part of the weight mean is just the same as n. Okay? So if we divide this part to this part, we'll have the average, the mean. You can write the same with the function power sum equal. I don't know how is power sum in, let us see. Well, this is power sum. I won't try to remember it because it's quite hard. This is the power sum equal power sum, which means that we are having the product and then summing everything together. This is the power sum, and these. I will not try to write it down because it's hard for me in Hungarian. So this is power sum. So this part we are multiplying by this part and dividing the sum of this part. Okay, girls, do you follow? Yeah. Okay. Good. Okay. So right now we understand what is weighted mean, when we can use it, and how we can use it. Okay? And we understand that in part of our evaluation from one creature to the other, this in essence is the same, but this is used on different and the last step of our evaluation is expected value. It's a mathematical term that asks what we are expecting. So if we have, if we ask how tall will be a random, let's say, woman that will enter this classroom, we will give the expected value, which will be the average value. We will say that we are in Hungary and the expected average will be around 163 or 165 centimeters. I don't know what the average is for a Hungarian population, but we will say that we expect that value, which will be the same as the average, which will be our expectation. Okay? When we are using the expectation, when we don't know the proportion, the n, okay? Because, for example, if we throw dice, in general sense, we can throw dice indefinitely. So the calculation of dice throwing is goes to the limit to infinity, because we can throw dice indefinitely. In that case, we can't just sum all the cases of dice and divide by infinity. Okay, this will not hold. That's why we'll use expected values. So in cases when n is unknown, so we don't know how many instances we have just the function that outputs the results. If we want to know where is the average, we'll use these two expected values to understand what is the average. Okay? So right now we understand what is expected value. Let us understand how are we going to calculate it. Okay. I am going to change a little bit this. Okay. This. Okay. And I am going to copy this and add it here. And let's delete all this. Delete. And this won't be the frequency, but this will be the frequency and density. Density. Okay, density. And it won't be, let's call it not Wi, but di, because this is different. Di, okay, density. Okay. What is density? It just mathematically states what is the probability of each outcome. What is the mathematical probability of each outcome? Let's assume that this is our general population, and we get 5 2 times, 6 3 times, 8 3 times, and so on from 12. So what will be our probability of getting, let's say, 0, or getting 5? We can calculate it by dividing the part to whole. So we can calculate it by simply saying that we want to divide this part to this part, and we'll log this part down by F4. So dollar signs. I hope you know that's logging the F4. You have learned about this now. And entering it and going down. Okay. So we have not frequencies but density, the probability. So the probability of getting 6 is 1 to 125. The probability of getting 8 is 1/4, and so on. And if we sum up all the probabilities, we'll get 1. And it is expected. So, okay. So in this case, how we can calculate the average? The average. if we don't know how much each case is, we just know the probabilities of each case. We can do so by doing the same. At this stage, we are just how do you call like this part? We are multiplying, yes. I don't know why I forgot that word. So we are multiplying the cases with their probabilities. Okay? So case multiplied by probability, case multiplied by probability, case multiplied by probability. And if we sum up all these cases, what do you think we will have? We'll have the average. Okay? Yes?
Sorry, if you can repeat how we can find density, please.
Okay. It's just probability. So how much time you are expecting to have that probability? For example, if we have dice, and we want to calculate the average value of a dice, how can we calculate the average value of the dice? We know that the dice have 6 faces. 1, 2, 3, 4, 5, 6. No? And what is the probability of each face? What is the probability of each face? Like you are throwing the dice. What is the probability of each face?
So I think that here we can.
What's the guys? If you are throwing dice, what's the probability that you it'll be 1 or 6? Each face has equal probability, no? So if you are throwing dice, each face has a probability of 1/6. It's equal probability that you get the face of dice. So in this case, the probability will be 1/6. 1/6. Okay. 1/6. And if we sum up all the probabilities, you'll get 1. And we can do the same. We can just multiply this part with this part. Okay. Multiply all the parts, and sum all these things together. And we'll have that the average value, like the expected value, or the average of dice is 3 and 5. Okay? So, let's go to the internet and expected value. So, the expected value, then how we have discrete cases, the equation for expected value is this. So the expected value is just the expected value of expected x is just expected value is just sum of individual things multiplied by their probabilities. Okay? Expected value. When we have a discrete case. and we use expected value when we don't have n. In the case of throwing dice, in the case of the function that throws dice, we don't know the n. We cannot throw the dice indefinitely. No? That is why we are just multiplying our what we have with the probability to get the expected value, which will be our average. I feel like this part was hard for you to grasp, or do you have some questions? Please ask them, so I can show you or repeat once more some parts. Do you have questions? Okay. Okay. I'll say that I did this part too fast, and you don't have this part in your sheets. Okay? But I hope that you understood what I am doing. Okay. Any other questions? Do you need me to help you or something in your computers? Okay. No. You this I'll show you. Oh, sorry. I'll show you once more time. In this case, what we are dividing towards. We are dividing. Let's see, this part to this part, because this is our whole. This is our whole. We have 12 instances. No? This is how many times in 12 we got 5. So we'll divide one part of the frequency to the whole frequency to have the answer. Okay? And look up this cell. So each time you are dividing on the whole you have. Okay?
Yeah, but it doesn't work.
Let's make it. Okay. No, not 5. 2. 2. 2 divide by 12. F4 lock it up. Okay, I see.
It's a data.
It's a data. Okay. Okay.
Thank you.
Do you have any more questions? Everything capish? You understand everything? Okay. So, by the way, this summation, like expected value, when we have a process, a random process, that outputs some values on based probabilities, a function of process, we can calculate the average or the expected value using this formula. Like each output, the sum of each output multiplied by its probability. But we can do this if we have a discrete process. When we have not a discrete process, but a process that is continuous, we just not use the summation, but use integrals. I hope you understand what I'm saying, okay? You do, I feel like mathematics. Mm-hmm. Okay, for the rest, you will learn about integrals later. Okay, but they are just summations for continuous things. Okay, should I continue? Okay. let's go to the top called trimmed mean, because this we are continuing to learn about means, and the continuation is trimmed mean, like trimmed mean. You know what this word means, trim. It means like we are cutting down something, like trimming the bush or trimming the hair. Okay? What is trimmed mean? As we learned, the simple mean is not robust. Extreme values have huge, have a huge impact on the mean. So, and extreme values we can have extreme values from both cases, from the maximum and the minimum. So, how can we make the mean more robust? And we can do it using trimmed mean. Trimmed mean is just calculating the mean, but we are just putting away or trimming the maximum part and the minimum part. So we are trimming the extreme values to have more robust statistics. You have seen the trimmed mean in the skating contests, when the judges, the skating or contest of the girls that are skating, and judges, Olympic skating, judges of different countries give scores, no? You have seen the trimmed mean there, because the judge may like the participant from his country and give higher score, no? Which may be an outlier. Are you listening to me? Or?
Yes.
Okay. Which may be an outlier. In this case, in figure skating, the 5 judges are giving the score, but the minimum value and maximum value are trimmed away, so there are no outliers, and the score is calculated based on the remaining 3, and it becomes the mean score. So there won't be any outliers that have an effect on the final score. Okay? Before I continue, I feel like you are busy trying to understand something, trying to calculate something. Should I give you some time to finish, or should I continue? Okay, I'll continue. Okay. So the trimmed mean, just trimmed mean, I'm not going to calculate it right here. Just put it away. You look through your, I'll give you the sheets, take them home if you want, or email them to you, and open them in your computer. If you open them in your computer, they will be translated in your Italian and you'll understand. And girls, if you open those sheets in your computer, they will be translated in your language, in the French, and you'll understand them better, okay? So I'm not going to go through this sheet. I'm just going to say that trim mean, the function of trim mean, trims the top and the lowest 5 or 10% of values, and calculates the mean, the average, based on the remaining values. And this statistic that we'll have eventually is more robust. So we can be sure that extreme values, in this case, don't have an effect on our mean. And thus we can calculate the trim mean. Okay? I'm not going to explain the geometric mean, but I have a question. Do you remember in your when you are taking the exam, where is the geometric mean in the examination? Geometric mean.
I didn't take part in the exam last year, so.
Okay. So you don't remember if you geometry. I don't want to speak about geometric mean. I don't think it is in your curriculum, geometric mean.
I know what is, but yeah, I've done in Italy.
Geometric. The geometric mean mainly is used in percentages. If you are trying to calculate the average percentage, it's a mistake to use just simple average. You must use geometric mean. So if you have something that grows, so you learn finance, as I presume, finance or something like that.
Yeah.
Because this tool is used in finance, not in statistic geometry.
No, so in Italy I've done another statistic course,
Okay.
and was with arithmetic, mean, geometric,
Okay.
and all of them.
Okay, all the means.
Yeah, all the means.
Okay, all the means. Okay,
But just because it was a theoric course,
okay.
not practical.
Okay, so you are telling that I am teaching more practical.
Yeah, and it's better.
Thank you. Okay, I'll write down. Geometric mean is like in the case of arithmetic mean, just mean. We are just summing all the x's and dividing by n. In the case of geomean, we are multiplying all the x's. This is multiplication. And putting in root n. That's the whole gist. But I want to say to you that in real applications, in real world, geometric mean is used only with percentages. So if we have a percentage growth or something percentage, and if we want to calculate the average percent growth, we won't use the simple mean to do that. We'll use geomean. That's all. That's all I will say about geomean. I don't want to say more about it. Okay? If you have any questions about geomean or anything else I've said prior to this, please ask. So I am sure that you understand everything I say. Okay? Should I continue? Okay. The next slide, which is called percentiles and quantiles, is the continuation of the idea of median. Okay? Because like the weighted mean, expected value, and the trim mean were the continuation of the mean, of the average. Like the idea of the mean, the average. The percentiles and quantiles are the continuation of the idea of median. Okay? Of the idea of median. Because you might have some other interesting problems. For example, in this case, we have bachelor students. We have final scores. I don't like that it's 0 here. Let me check. Ah, 100. Yeah, it's not 0, it's 100. Okay. So we have some bachelor students, and the rule says that only top 25% will have a chance to go to masters. So it isn't like a known number. It must be calculated from the data. If I said that only top 50% can go to the masters, apply for it, it would be easy, no? You would have calculated the median, because median divides our data into two equal parts. 50%, 50%. But in this case, it is said that we must choose the top 25%. And it is done using the percentiles. By the way, this is percentile is not the official statistical term. Okay? Percentile is the function that Excel uses. I don't know how even is percentile in Hungarian Excel. Let's check it out. Percentile, no, similar, it's similar, but the real term is quantile. Quantile. Quantile.
No, I don't know. In Italian, I know this in Italian. Quantile.
Quantile. The real term is quantile, which answers if we have data, which point of our data divides our data in arbitrary percentages. You understand? If it's the 50%, it's the median, 50-50 median. But we might ask, what is the arbitrary percentages that we want to divide our data into? Let's say, what is top 25%? Or what is the top 10%? Or for example, I hope I think you remember that quite a few years ago in America there was a movement 1%, top 1%, 1%. How we can calculate that 1%? Like if we have a sample, a huge sample, what is that point that divides 1% from the rest? Let's say, what is that point that we can calculate, that we can say that from this point it's 1% of all data, and below it 99% of the data. Okay? We can use it using quantiles. Okay? Using quantiles. 50% quantiles is the same as median. But we might be interested in other numbers. And this is one of the main functions in statistics, okay? The quantile function, which answers for the given percentage for the given probability, which number we have that is low from that number and which is higher. Okay? Understood? Okay. Now you can see that if we are dividing into two quantiles, it's made 50-50%. Let's go back to this and let's calculate. Okay? Excel uses the term percentile to calculate quantiles, but why is it using the term percentile to calculate quantiles? Percentile, if you see here, percentile is the 100 quantiles. So percent, 100%. Percent is 100. So if we are dividing our quantiles to 100 equal parts, then we have percentages. So Excel isn't just using the term quantiles for this function, it is using percentile. But you can calculate by this function arbitrary quantiles, okay? Okay. So in this case, I'm not going to show you how the percentiles are calculated, I can say that there are quite a few different mechanics or different equations that calculate the percentile. As far as I know, there are around 8 or 9 different different variations of the same equations to calculate percentiles. Excel only uses 2. Okay, and Excel uses 2 functions to calculate percentiles. The first in English is percentile excluded. The second is percentile included. Those calculate little bit different percentiles, but at the end give similar results. Okay? They can just let me see. Okay. What was the function? Okay. This is percentile excluded, and as I believe, this term, which is ESI, means excluded. No?
Yes.
Exclusion, excluded. There is also included dark almas, which means included.
Yes.
Included. Okay. And we can say like our data, our array, this is our array, and state the percentage for which we want to find the top. So in this case, we want to find the top. In this case, we want to find the top 25%, no? We write in this case now 75. Why we write now 75? Because percentiles are calculating from the bottom part, from the left, from minus infinity. Okay? And if we want to find the top part, we are just minusing the whole, which is 100%, from that percentile or quantile, 25%, and we'll get the number. Okay. So this says, if we have at the end of the year, if our students have those marks, and we want to find out which top 25% can have and could have an opportunity to go to masters, we'll say that only the students that got more than 88.75 could have gone to masters, and only those students in our list will have that opportunity. And visually, if you look at this data, then we can see that yes, around 25% of our data is here. Yes?
Doesn't work. I'm sorry.
Let me see.
This one is the
Okay.
right?
Idiosyncrasies. Okay.
Uh,
You
No.
just can't. You can't just simply write like no
okay.
75. Okay. Second argument. You have a little bit different number. Please check.
Okay.
100.
Okay.
They should be 100. Okay. There is a mistake here. It's now changed to 100. So it's not 88. It's 100. Okay. This is percentile. Okay. We'll continue like speaking about percentile, so you understand it more. But I will say that I will repeat myself, saying that there are around 8 to 9 different equations that calculate the percentile. They are quite similar and give the same result, around the same result. But Excel only uses 2, percentile included and percentile excluded. What is the difference between those two? And what excludes or includes the percentile? Okay, percentile included includes the maximum and minimum, the 0 and 1. Okay, so you can give 0 and 1, so maximum and minimum to it, and it will output the maximum and minimum numbers. So percentile included with 0 will output the minimum. Percentile included with 1 will output the maximum. But excluded assumes that this is a sample, and in a sample which is driven from the function, there is no true maximum null, and there is no true minimum. The maximum 1, and there is no true minimum null. So it will give error. But in the rest, they are the same. Okay? Do you understand, girls? Okay, that's great.
Sorry, this doesn't count for me because this is the form.
Okay.
No.
Enter. You have the English.
This
Okay.
is the person that exclude.
Okay, you need to put comma, not comma, dot comma. This should be a point. This is other idiosyncrasies of Excel because it varies from region to region.
Yeah.
Okay.
Oh.
In some cases of Excel uses as separating arguments. Excel uses just simple comma. In other regions it uses comma with dot. Okay. Why? Okay. Let's go back here and calculate some percentages. Because we might want to ask, what is the 10% of the population that has the highest income? Or what is the 10% of population that has the lowest income? Okay? Let's do that. First of all, let's calculate let's calculate the quantiles like this. Quantiles. Let's calculate the quartiles. Quartiles means 4. Quarter means 4. So it is like median divides our data into 2 parts. Quartiles divides our data into 4 parts. We just use the knife of statistics and divide the breadth of our data 3 times, it will give us 4 equal parts, which each of which will have 25% of data. Okay, and we can do it. Let's come back here. Let's say 25, 25, 5, 75, and this will be Q1, the first quartile, Q1, Q1. This will be median, which is the same as Q2, and this will be Q3. Okay, this is the official notation, and we'll use this function percentile excluded. Here, Control Shift down to choose all our data, then F4 to lock it up, then comma or comma with dot, it's like how, and our percentage which we have written here. Okay, and let's go down. Let's check the last. Okay, the data is the same with it is logged by F4 and no 75. And let's give this a bit, let's make this to look a little bit better. Let's like here, and we don't need the cents. Okay.
Now this.
Did you manage to do it or?
Could you show the cool one again? Because I
Which one?
signed the first.
Okay, Control Z, Z. I just
Oh,
said
okay.
that I want numbers, just see, and I don't want the cents. I think this means numbers. EGNE. What does EGNE mean?
The individual.
Yes.
Individual,
Yeah.
like a person, an individual.
No, individual, just one. Right?
No, this is
Customized. Yes.
Customized.
Mm.
Ah. We can use anything, but this is what we have. And this says that okay, take your time.
Yes. I'm coming.
Oh, you have the English version. Okay, that's great. Let's just,
Yes.
you know what? Let's say
You
that
can
both
see
of
that.
those words involved for themselves. And we have one number. We want a separator, and we don't need the cells. Okay. So anything will go here will be in good format. Okay. So right, the
But you have to use the dollar sign to.
This one, right?
The dollar sign, you know, this, the dollar sign.
complicated.
Before the
Keyboard, I
Before
don't
the,
know.
before the
FX.
number.
This must be
Mine doesn't say.
percentile.
Okay.
Okay. Array should be all these.
before
Lock it up. And the percentage should be here.
Copy this from this side because mine doesn't say.
Okay. No,
This,
percentage should be
this all here.
okay here.
and
Okay. It is 25. This is 5. This is 75.
Good.
We put it down. It will work. Okay. Sorry for doing this too fast. If I'm doing too fast, just tell me. I know Excel very well. I might do some stuff very fast. Okay? I know Excel so much. I know Excel so much that we have a love-hate relationship with it. Okay?
so later.
This is the formula, but mine doesn't work. The formula doesn't work again. This is the first one.
You need just simple, no, not that one. Okay, this one. Okay, valid. Alright. Why does it do 9?
Et après, il faut juste que je tire ma passion.
No. Maybe this is not right. The center is easy. Array. Ethics. Down. A is error invalid. Maybe we have something that is not a number here. I don't know. What is that case? No, everything is a number. I don't know.
No, I think that you can close this one. Later.
Let's put included. I don't understand. Okay. Okay. Should we continue? Okay. So it says that 25% of our population, do some sample, 25% of our sample has less than 132,000 theories. The next 25% of our populations earns from 132,000 to 230,000 theories. The next 30% of our population earns from 230,000 to 365,000 theories, and the richest 25% of populations earn more 365,000 theories. We can do the same using decimals. Like we use Quantiles to divide our population in 3 parts, but we can use decimals to divide our population in 10 parts. Okay, let's do this, and decimals out, if we divide one whole into 10 parts, the 10 parts will be it'll be 1.1, 1.2, 1.3, and so on. If we take this and continue, Excel will calculate this properly. Okay. Okay. From 1 to 9. Okay. This will be our decimal, and we can write down this. This will be D1, D2, D3, and so on. 5 is D6, D7, D8, D9, okay. And we just can copy this here and it will calculate correctly. Let's check. It chose data, we logged the data, and it chose the cell, the percentage. Okay? And we can pull this down and it will calculate the rest. So, 10% of the poorest population we have. Yeah.
You can repeat the last step.
Okay. I'm just what I have. This part is logged. This part says calculate using 10%. In a case, the rest is logged. I'm just pulling this down. It calculates automatically because this part is logged and this says calculate with 90%. Okay? Just do this and I'll explain.
The other you okay.
That's fine.
Ouais, c'est ce que j'ai fait, parce que je connais pas. Ouais. Je sais pas du tout.
Okay, say when you're ready, and I'll continue. Okay? Let me see.
Because these
Okay.
didn't work
Okay.
the same problem.
These are just numbers. These are not calculations, so I don't know.
Yeah.
Yes.
I have the same problem.
Okay. Center is up. Data. Control Shift down. F4 locked up. Then this thing. Down, left, and close it up, enter, AirTag. I don't know why it gives the error for the front. So everything is right. Okay, maybe, I see the error. Okay, I see the error.
So then mine will.
Okay, you must put dots here.
I wrote the numbers because mine
Okay.
didn't work.
Okay, the idiosyncrasies of Excel. Some versions of Excel say that you need a point for decimal marks. Some say that you need a comma for a decimal mark. So if you are putting here comma and it doesn't work, it means that you put not comma but dot. So Hungarian Excel uses comma for a decimal mark. And English Excel uses dot for a decimal mark.
No,
But
I-
Hungarian Excel uses
so I
dot
have to use
and
the dots.
point to differentiate between variables like this one. dot and point,
What?
dot and comma. The American Excel uses just comma to differentiate between variables. So the idiosyncrasies of Excel. Okay? Okay, you got it? So I'll continue. In this case, we found out from our data that the poorest 10% of our sample has the wage of less than 81,000 florins, and the top reaches has more than 539,000 florins a month. We can also find out the top 99%, a total 1%, but I advised against it. I'll say why, but we can do it. I can say not 99 and okay, and copy the same thing to calculate, and it will calculate that the poorest 1% earns less than 30,000 florins, and the most like the richest top 1% earns more than 1,100,000 florins. But why I advised against doing this? Because this was calculated on a sample, and sample may be different than a general population. And if we are going too close to the extremes, our sample may be much different than the population is. Okay? We might need a huge sample to go to the extremes like this, but this may give you a general idea what is the highest and lowest 1% earning. Okay?